All right, so today for 6-2, our objectives are we're going to be able to find the slope of a graphed line, and we're going to find the slope of a line passing through two given points. So if we just have the points and we don't have the graph. You guys said you already learned slope last year, several of you, which is awesome, even better. So the slope, or M, right, always represents our slope. It's going to describe the incline or the steepness of a line. Okay, so it can be positive or it can be negative. So one is going to describe the steepness going up from left to right, where the other one would describe it coming down from left to right. Okay, we'll get to that part as well. But slope then is the ratio of the vertical change, which is the rise. So vertical change we call rise, to the horizontal change, which is the run. Okay, what's vertical? Up and down, side to side. What is vertical? Up and down or side to side? Up and down. Okay, so up and down. So I'm just going to draw little arrows in there. So what's horizontal? Side to side. Okay, so we have our side to side. These are all the different ways that you can calculate slope that we're going to be talking about today. Okay, we can describe the slope as the rise over the run. We can write an equation to solve where we have 2 points and we subtract our y values and divide them by the x values, or write them as a fraction, or that ratio. We can describe it as the change. In Greek, the triangle is a delta, which means change. So it's the change in our y over the change in our x, which is the exact same of what we're doing here, the change or the difference. Or we can actually write it out in words, change in y over the change in x. All of those are ways that you're going to see or hear slope talked about from here on out. Okay, so if we look at this graph, which we're going to use it a couple times, we've got a few points picked out there, A, B, and C, so we're going to use those. But this is when we're talking about the rise and the run. If I want to go from A, this point that's 3, 1, up here to B, okay, I need to find my slope. The first thing I need to do is do the rise. So how many up did I go?
3.
How many? I rose 3. Was it a positive or a negative? Positive, because I went up. Okay, so my slope, since it's the rise over the run, my slope is going to be the positive 3 over, okay, over 2, because I've got to get from here to this point over here. So I went over 2. And I went right, so that's a positive. So both of these are positive. So my slope is 3 over 2. And no, I do not want to make that 1.5. Okay, I want to leave it as 3 over 2. You don't simplify slope, you prefer it to be a fraction, because you'll use it to graph another point. To graph the next point on this line, you could go up 3 again, and then go over 2, and you would put another point, and you could continue this graph. The really cool thing is you can go the other way as well. Instead of going up 3, you could go down 3. So 1, 2, let's see, 1, 2, 3. And then, so this way I went down 3. And then I should go, instead of going right 2, I can go left 2, which is a negative 2, and I get a point on the line. So my slope is also negative 3 over negative 2. Good, good. Okay, so we're going up 3 and right 2, or we can go down 3 and left 2. Either way, we're going to find those points. So you want to leave it as a fraction. Okay. So let's look at example 1 and find the slope of the lines. Can you find? Okay. So can we do A? Can we find the slope of the line there? Can you pick 2 points? Give me 2 points. Connor, give me 1 point on that graph that you can see really well. 2, 2. Okay, 1, 2. That'd be perfect. All right, so from 1, 2. Bailey, Malin, give me another point on this graph. 3, 1. Okay, I wrote my. No, you're okay. I'll just change that. I'll just move my writing, and I'll write it up here. So I've got 1, 2, and then you said 3, 1. Yeah. Okay. So if we want to get from one to the other, Cheyenne, how do I get there? First of all, where do you want to start? You want to start the 1, 2 or the 3, 1? The 3, 1. Okay. So remember, slope equals the rise over the run. So how much am I going to rise from 3, 1 till get lined up? Cheyenne? 1. Okay. And how much do I run, Cheyenne? 2. And did I run left or right? Left. So that's going to be a negative. Okay, so it's negative 1/2. Okay, the other thing with this is it can be negative 1 over a positive 2 as well.
Is there a difference?
There's not. That's good because I could go, same thing. I could go down 1, that's my negative 1, and I could go right 2. There's my negative 1 over 2. It just gets me a different place. Earlier when I had 2 positives, I went up and to the right. The opposite was going down and to the left, so doing 2 negatives. So this is just how we can graph more points. If we plot one point and we want to go above it or below it, we can do that. So it doesn't matter. A lot of times you're just going to see it as negative 1/2, and you know you can apply the negative to the 1 or to the 2. It doesn't matter when you graph it in the least. Okay. All right. B is a little tricky. We haven't done one like this. All we looked at was the graph. So up there in your formula, okay, those formulas, which formula is going to help you? We're here. Look at those formulas I gave you. All the formulas we could possibly use for M up above. We could think about, yes, the change in the y and the change in the x because they gave us 2 numbers. Okay, so we can think, well, it's the change in y over the change in x. What does change mean? The difference, so I need to subtract. So that's where that other one, too, that y2 minus y1, that's where we're going to find the change, divided by the x2 minus x1 comes in. Okay, the order in which you subtract these doesn't matter. What matters is that you always start with the same point. Y is always first, but what I'm saying by that is like if you're going to use like this is your first value and this is your second one, so maybe you want to start here. Okay, you have to do 4 and 1. Like, okay, they both have to be the first number in these problems. You can't start with this one and do 4 and then this one do -3 in your denominator. They have to be in the same order. Okay, so well, we start with this one. What's my y value in 4, 1? 1 minus, what's my y value into -3? So 1 minus -3 divided by, okay, what's my x value I'm going to use? I have to go back to this problem and use the 4. Minus, what's my x value? 2. Okay, 1 minus -3 is 4. 4, 2. Okay, so it's not a -4, right? Because 1 minus -3 would be like plus a positive. Okay, so this can be simplified. What would we simplify to? 2. Or 2 over 1 if you need to. When you're graphing it, 2 over 1 is going to be ideal. But so 2 equals M.
Well, I got a completely different answer because I did mine the other way.
-3 minus 1?
Yeah.
Shouldn't matter. Okay? That's what I was saying earlier. As long as you start. So if we do it the other way, -3 minus 1 over 2 minus 4. Negative 3 minus 1 is negative 4. 2 minus 4 is negative 2. Still reduces to 2.
Wait, how come it's like that?
How come it's like what? Well, because here's the thing. You were always told subtraction is not like addition, like you have to put them in the right order. But now that you know about negative numbers, it's not exactly the case, because we know that subtracting is the same thing as adding a negative number. So now that you know that, it's not the same. It's the same thing like,
Can it be 2 minus 4 first over?
oh, that part matters because it's the rise over the run. So you have to get the numbers that
So
give you the
it's
rise.
X over Y. I mean, it's Y over X.
It's y over x, always, always, always. Because y gives you that vertical change. And that's what slope is. It's the vertical over the horizontal. Okay, so yeah, if that's where you flipped them, that's where your mistake was. That's not one you can solve, but you can definitely put your ordered pairs in any order and subtract them out of any order. Okay, all right, so then at the bottom there, we talk about the different slopes that we have. So if you have a positive slope, it's going to go uphill. So you might have m equals 2 over 3. Okay, it's going to look like this. It's positive. Negative slope is the one that goes downhill. So you might have m equals negative 2 over 3. It's a negative slope. When we have a horizontal line, we have 0 slope. And when we have a vertical line, it is undefined. Our slope is undefined. So there are 4 different types of slope that you can have.
So, like we do homework, do we have to label?
There are a couple where you have to label like to describe the slope. If it's positive, negative, no slope, or 0 slope, or undefined. Good question. All right. Then on to the back. So example 5 says graph the line passing through the point -1, 2 with a slope of -1/3. So our steps are here. First, we're going to plot the point. Okay, so we start our origin, go back -1, up to +2. Now we get to plot more points. So step 2, using the slope, which is that -1/3, plot more points. Okay, so that's what it says -1/3 equals -1 over 3 or 1 over -3. Try both of these. That's what I was talking about earlier. So how would we do -1 over 3? How would we do this one? Not over, because remember it's rise. We have to go up and down first. I'd go down 1. I'd go down 1 and right 3. 1, 2, 3, and I would put a point right there. And I could do it again. I would go down 1 and right 1, 2, 3, and I could put a point there. Okay, those lines are not necessary. Huh? That's what it says. Graph it. And then, so let's try the other one though. Okay, let's try 1 over -3. Okay, Cameron, how would I graph that one?
You would go
Up 1.
and over 3.
Left or right?
No,
Left.
left.
1, 2, 3, and I would put another point. Yeah, perfect. And then it says draw a line passing through the points. Okay, that's how we graph it.
It's like it's too good to be true.
Yeah, right? There you go. There is your line that passes through that point and has this slope. We just use the slope to add extra lines when we're graphing. Good. Good, good, good. All right. Then let's look at this real world problem. I like it. I feel like I sense a little sarcasm, but I like it. Okay, so example 6 says determine the speed of the train for each section of the graph. So from 0 to 2 hours.
There's no speed.
Ah, there is. You have to determine it. How are you going to determine it? Miles. Oh, check that out. Okay, so that's good. Speed is miles per hour, or we might be better off to say miles per hour. What does that look like? Miles is the vertical change. Hours is the horizontal change. So it's the rise over the run. So it's the slope. If we can find the slope of each section, we can determine the speed. Yeah, so from 0 hours to 2 hours. So how much are we rising here? Which I can't see. I'll say I have to pull it up on my graph on the book. 70, okay. So the slope is going to equal, we rose 70.
Wait, I don't get that.
Okay. My graph is not real great. But we're going from this point here at 0 hours to the point that's at 2 hours.
So?
Are you saying so to me?
No.
Okay. Well, I'm like, no, it's just, it's kind of, the screen's kind of fuzzy.
I'm just confused. Where'd you get 70 at?
Okay. So like if we brought this point over and it looks better on your graph than it does on mine, that would be, it's right in between the 60 and the 80. So that number would be 70. That's okay. So that we rose 70 and then how many, we went to the right. So this is positive. 2. Okay, so 70 over 2 is 35 miles per hour. It is everywhere.
I know, why is it so easy? Yeah.
Okay, so next we need to do hours 2 to 4. So we want to go from hour 2 now to hour 4. So again, so we're starting at 70 though. This is where we think about our change. Okay, so we're starting at 70 minus, or doesn't matter how we want to do it. It might make more sense to you to go up to the other number. It's right at 180. Okay, so let's,
40 miles per hour.
so it's right at 180, but we need to subtract the 70 where we started. Okay, well, let's go ahead and set up our,
Have to subtract that.
yeah, because we're,
That's from before.
yes, that's from before. Good call.
I did not know.
That's okay. That hopefully this will help you understand why we subtract them to find the difference. It's because it's like we're starting from this point, not from the other one. Okay, and so then
Divided by 4.
we went over to, okay, well, it was 4 hours, but we'd already traveled 2 hours because this distance here is 2 again. So we would say 4 minus 2. So we've got 110 divided by 2 is 55 miles per hour. Good. Okay, and let's look at our last chunk. Okay, so hours 4 to hour 7.
260.
Oh, no.
70.
No.
Okay, what do we think? It's how much? 270? Yeah, I would agree with 270. Okay. So 270 minus, where did we start? 180. Good. Over, what time was it here? 7 minus 4. Okay. So 270 minus 180. 90. All right, 7 minus 4? 3. 90 divided by 3?
30.
So we've got 30 miles per hour. Okay, so at this point, we could, yeah, I was like, we could definitely determine when did the train travel the slowest.
C.
So tell me the time. At what time did the train travel the slowest? 4 to 7 hours, not 7, but that 4 to 7th hour. Okay. When did the train travel the fastest?
2 to 4.
2 to 4. Okay, from hours 2 to hour 4. All right, perfect. Okay, well then you guys are set to start on your homework. Yes. And I'll give you some graph sheets again.